Okay, so before we get started, I want to make sure we understand something that was given to you in the notes, and it's called the zero product property. So let me explain what that is, okay? The zero product property is something you're going to use to solve polynomials. Okay, so if you're asked to ever solve a polynomial, like solve for x, you're really using zero product property, and we use it to solve polynomials. And we talked about polynomials last week because we were adding, subtracting, and multiplying them. So how do I use the zero product property? First thing we want to do is set equation equal to 0. You cannot use the zero product property. You cannot start doing it until your equation is equal to 0. If it's not equal to 0, then we cannot start this process, okay? Once it's equal to 0, we want to turn our problem into a product or a multiplication problem. Okay, and this is the hardest part of the whole thing. Can you turn a problem into a multiplication problem? This is done by what we call factoring. And hopefully in Im3 you started dealing with factoring. I know if you had my class, we were really getting into factoring. We were doing it quite a bit actually. Okay, so if you had me for Im3, hopefully you recall some of that factoring. All right, so in order to do this, you have to set your equation equal to 0. And then this is the hardest part of all. Turn your polynomial into a multiplication problem. If it's not done already, our job is to do that. Okay, and this is where we're going to spend a lot of time figuring this stuff out. Okay, once you do that, the zero product property says set each factor. Okay, so a factor is the things that are multiplying equal to 0 and solve. Okay, and this is basically how we are going to solve polynomials or solve certain equations using these steps here. Again, they're explained a little bit differently on the video from Monday, but it's essentially the same idea. Okay, so let's check out number 1. We want to solve the equation. Okay, and in order to solve the equation, we got to make sure, is my equation equal to 0? If you notice, it is. Okay, the next thing we're going to try to do is turn our polynomial into a multiplication problem. So if you look at what we have here, if you read this polynomial, this is actually already into a multiplication problem. The two parentheses are saying, hey, this guy is being multiplied to this guy. This is already a multiplication problem. A fancier word for multiplication problem is we want to turn it into factored form. Okay, which means a multiplication problem. So if you look, the reason it's called factored form is because this is considered a factor. Factor are 2 things or 3 things or 4 things that are being multiplied. So we actually have 2 factors. Factors are guys that are multiplying together. Okay, so this is in factored form because this guy is multiplying with this guy. There's nothing adding to these individual parentheses. They're not being divided by anything. It's just straight multiplication amongst the parentheses. When this happens, we have already done step 2. It is done for us. It's in factored form. It's in multiplication form. Okay? Because it's in multiplication form, we could set each factor equal to 0. So in essence, we have 2 factors here. We're going to take each factor, so x minus 5, and we're going to set it equal to 0, and then we're going to do x plus 3, and set that equal to 0. And this is considered solving by factoring, okay? Putting it in factor form and solving. Now we just have to solve each equation for x. So solving these equations, I'm just going to get x by itself by adding 5 to both sides. And hopefully you're comfortable by solving now. So one of my answers, in this case, I'm going to have two answers. I have positive 5 as one answer. And then I'm going to solve the next equation. Subtract 3. Negative 3 is another answer. Okay? And we have solved the equation using the zero product property, which is outlined here. Okay? Let's jump over to number 5. Okay? 2 and 3 are exactly what we just did. So let's jump over to number 5. Is my equation, before I can solve, is it set equal to 0? And the answer is yes. Next thing is, where I have all the variables and numbers, I need to turn it into a multiplication problem. And if you look, it's multiplication. We have this factor, and it's multiplying with another factor. When that happens, step 2 is already done. We didn't have to do any hard work there. Now, step 3 is, once you have your factors, set each factor equal to 0. So we're going to have 2y plus 5, and then 7y minus 5. And now we have to solve each factor. Since we have two factors, we're going to have two answers. So if you remember how to solve, we're going to subtract 5 first. We have 2y equal to negative 5. And then we're going to divide by 2. And y is going to equal negative 5 over 2. I'm just going to leave it as a simplified fraction. So there's one answer. And let's do the same over here. We're going to add 5. We get 7y equal to 5. And then divide by 7 to both sides. And y equals 5 over 7. Since there's no other factors, those are my two answers. Okay? Cool. So that is how we solve using the zero product property. All right? Next section, 6 through, I think it's 11. All we're going to do is use a factoring method. So again, we're going to get comfortable with step 2, where we actually have to use factoring methods. This is one factoring method called GCF. Okay? And what GCF is we're trying to divide away the biggest number or greatest number and variable okay. That's what we're going to do, because if we can divide it away, we then, after we divide, are able to turn it into a multiplication problem. And remember, to factor, to solve, we eventually have to turn it into a multiplication problem. So one of these methods is called factoring by GCF. Okay? So if you notice right here, we are not solving here. So there's no need for equal to 0. That's only when we solve. Here we're just going to do this factoring method. So I highly recommend you watch the video on Monday to show how this works. So let's do number 6. So we have a polynomial and we have two terms. These are not factors, these are terms, because factors multiply with each other. These terms are adding with each other. So looking at these terms, what I like to do is ask myself, looking at the numbers. What is the biggest number I can divide away from 2? Okay? So in other words, what's the common divisor? What's the thing I can take out that they have in common? Okay? So my GCF, greatest common factor, that's what that means, is what can fit into 2 that also can fit into this 2. What's the biggest number that can fit into both of them? Okay? And that answer is 2. Right? 2 can be divided by 2, and this 2 can be divided by 2. That's the biggest number that can divide both of these. And that's what GCF is about. Once we do the numbers, we then look at the variable. If they have the same letter in each term, then your GCF would have that letter here. But in this particular case, they are different letters. So the only GCF I have is 2. Once we find the GCF of 2, it's pretty simple. We're going to take our original problem and we're going to divide each term by our GCF. In this case, we're dividing by 2. And then we do the math. 2 divided by 2 is 1, and bring down the x. So it's just 1x or just x. Positive 2 divided by 2 is positive 1. Okay, and bring down the y, so positive 1y or just y. So that is my polynomial after I divided my GCF. Remember, we got to turn it into a multiplication problem. So I divided out of 2, so that means to turn it into a multiplication problem, I put and multiply by my GCF. In this case, I'm multiplying by 2. Okay, and we have factored completely. I have just turned this into a multiplication problem. It's a factor of 2 times a factor of x plus 1. So we essentially have 2 factors here. Okay, let's jump over to number 8. Same idea, we're going to do GCF. So let's ask ourselves, by looking at the first term and the second term, we have 2 terms. What's the biggest number that can divide 7 and also 35? Okay. So what's the biggest number that can fit into both of them? So my GCF, if you know your multiplication, is going to be 7. 7 can divide 7 and 7 can divide 35. Okay. Now we look at the letters. Do they both have a common letter? And the answer is yes, they have a common W. So I'm going to throw the W in here in part of my GCF. But now I got to look at the exponents. I want to choose the smaller exponent. So that means I'm going to have 7W to the second. Okay? So that's the only variables I have in common. I am done. This is my GCF. I'm now going to divide my original problem by my GCF. It's very important that you get the biggest number possible, because if you don't, you're going to do extra work. All right, so we have that. And then just do the math. 7 divided by 7 is 1. Okay, I'm not going to write 1, but it's 1. And then W to the 5th, and we're taking out 2 W's. So how many W's are left over? You're going to have W to the 3rd. Okay, we're dividing out 2 of them, which leaves us with 3. Then we go to the next term. Negative 35 divided by 7. That gives me negative 5. And I have 2 W's, but I took 2 away. That means they cancel out. So now we have to turn it into multiplication. So this factor gets parentheses, and what did I divide away? My GCF is my other factor. Okay, this is factored completely. Let's jump over to number 11. Okay, now you notice we have 3 terms. So we want a GCF. So we look at the number 6, 21, and 15. And we want to ask ourselves, what is the biggest number that can divide all these guys? So the way I like to do this when they're dealing with a lot of numbers is look at the smallest number possible. In this case, it's 6, and then just make a list of the things that can divide 6. I know 6 is the biggest number that can divide 6, 3, and 2, and 1. So these are the only numbers that can divide 6. So I want to check, can any of these numbers divide these 2 numbers? So let's start with 6. We know 6 can divide 6. Can 6 divide 21? And the answer is no. So 6 is not my GCF. Let's go to the next biggest number, 3. We know 3 can divide 6 already. Can 3 divide 21? And the answer is yes, it can. Can 3 divide 15? And the answer is yes, it can. Since it's the next biggest possible number, this is my number GCF. It's 3. It can divide all of them. Okay? So that's one way you can kind of look and try to figure out GCFs. Find your smallest number, figure out what it can be divided by, and then test it against these guys. Okay? So 3 is my GCF. Now let's look at the variables. Do they all have a common letter? And the answer is yes, they all have a Q. So that means my GCF has to have a Q. So now I have to put the power. I want to choose the smallest power from my Q's, and that's going to be 2. Okay, there's no other letters. That's my GCF. Let's take my GCF and divide it away. So it's 3Q squared here, 3Q squared here, and 3Q squared here. Okay, so let's divide that away one by one. 6 divided by 3, that's going to give me 2. 5 Q's, I'm taking 2 away. That gives me 3 Q's left over. We're done with that guy. Negative 21 divided by 3, that's negative 7. We have 4 Q's, I'm taking 2 away. I'm left with 2 Q's. We're done with that one. Negative 15 divided by 3, that's negative 5. I have 2 Q's, taking 2 away, they cancel out. So this is one factor. My other factor is the guy that I divided away, 3Q to the second, my GCF. And there we go. We've turned it into a multiplication problem. Okay. All right. Let's jump over to the next section. I'll do a couple from there. So again, this is one method of factoring. You're going to learn quite a few methods, okay? This is one way to factor, GCF. All right. So number 12, we're going to actually solve the equation. So to solve, step 1, if you recall back here, I want to set it equal to 0. So if we look, it's already set equal to 0. Everything else is on the left side, equal on the right side. That's what we like. The next thing, which is the hardest part, is I want to turn our polynomial into factored form. And the way we do it is by using a factoring method. In this case, we're going to use GCF because that's the only one we really talked about. And once we factor, we're going to turn it back into a multiplication problem or factored form. So let's look. Right now, just some vocabulary. This is in standard form. And our goal is to use factoring. In this case, we're going to use GCF to turn it into factored form. Okay, and this is our process for step 2. Okay, in factored form, as I told you, is just a multiplication problem. We want stuff being multiplied together. Okay, whether it's 2 parentheses, 3 parentheses, 1 parentheses, we just want stuff being multiplied. So, if you look, I'm going to use GCF. So, the number here is 1. The number here is 6. We have this term and this term. What's the biggest number that can divide 1 and 6? So like I mentioned before, take your smallest number that you have and figure out what can divide my smallest number. Well, the only thing that can divide my smallest number is 1. Can 1 divide 6? And the answer is yes. So my GCF is 1 right now. That's the only thing that can divide 1 and 6. Now we look at the letters. Do they have a common letter? And the answer is yes, they have B. So the next thing I can put in my GCF is B, but I want to pick a certain power. Okay, so I want to pick the lower power. So this is B squared. This is actually B1. So we're going to use B1, but I'm just going to leave it as B. Okay, and to be honest, do I really need the 1 here? And the answer is no. Okay, if it's a 1 by itself, then you would have to put the 1 there. But since I have a B with it, I could actually erase the 1. So my GCF is really just B, or 1B. So I'm going to take my GCF and divide it away from my original problem. So it's going to be B squared plus 6B, and my GCF is B. Okay, and now let's just do the math. 1 divided by 1 is just 1. I have 2 B's. I'm taking 1 away. I'm left with just 1 B. 6 divided by 1 is just positive 6. And then my B's here eliminate. Okay, so this is my factor, and my GCF is also another factor. So I have just turned it into factor form. It's a multiplication problem now. Okay, so now I'm going to set this, put it back into equation form, put it equal to 0. Once we have it in factor form, take one factor equal to 0, take my second factor equal to 0. That's what step 3 says. Once you have in factor form, put each factor equal to 0 and solve. So my first factor is solve. B is equal to 0. That's one answer. And then we have to do some work here. Subtract 6. B is equal to negative 6. Okay, let's do one more problem. We'll call it a day. Number 15. Let's jump to 15. All right, first things first, we got to set this equal to 0. So what I tell my students is, more than likely than not, we want to put everything on the left side so 0 can be on the right side. So that means this 6K has to move across the equal sign. To move a number and variable together across the equal sign, we got to add or subtract it. So since it's positive, we're going to subtract it across the equal sign. What you do to one side, do to the other. This cancels or turns into 0. This over here, we cannot combine these because one's k squared and one's k. These are not like terms. So we're just going to write them as a polynomial. 3k squared minus 6k. Okay? And now we have it equal to 0. But it's in standard form, and we want to turn it into factored form like we talked about up here. Okay, so we're going to take GCF. Looking at the numbers, we're going to check the smallest number and ask ourselves, what divides 3? And we know it's 3 and 1. So I want to check the biggest number first. Can 3 divide 6 as well? And the answer is yes. So that's my GCF. So my GCF is 3. Now I look at the variables. They have common letter, so that means I have to put that letter in my GCF and take the lowest powered of the letters. So it's k squared, k1, so it's k1 goes here, or just k. So here's my GCF. Let's divide it out. This is all part of step 2, guys. Do this math here. We're going to get 1k, or just k. 6 divided by 3 is -2, and then the k's cancel out. This is a factor, and my other factor is my GCF. It goes in the outside. It goes into a multiplication format. Set them equal to 0, and now we can solve. So 3k equal to 0, that's one factor. K minus 2 equal to 0, that's a second factor, and we solve each one. So here, 3 is multiplying with the k, so to get rid of multiplication, we're going to divide by 3. K equals 0. Over here, 2 is subtracting, so we're going to add 2 to solve. K equals 2. Okay, and we're done. We have solved. All right, this is going to take some practice. Hopefully you've solved this in IM2 and got introduced to it there, but it does get more complex in IM3. So the check-in code today is door. All right, you are just